We've had some big snows this time of year.
March,
Yeah.
Did I write something wrong?
Did you read it?
Oh no, that's
Oh,
Right here.
Packard information. Yeah.
You want a formal introduction from the
No,
back
that's
of the
all
room?
right. My name's Bill Schwoebel.
Hi, Bill.
I have been coming down here to Tom's little group since I think the second meeting. I didn't make the first one. I was involved at the AACA annual meeting, and I guess it was February that year in '97. I heard about it when I was there, but I didn't come till the next week when a friend of mine who has since passed away, Tom Hespenheim, was invited to come down here. But I'm going to speak tonight about Stanley burners, and not being the greatest speaker in the world, I hope you can put up with my mistakes. But did everybody get one of these great forms that explains everything I'm about to talk about? There's about 10 more up here if you need one. The Stanley burner basically is the heart of the Stanley car. If the Stanley burner is not working right, then the car is not going to work right, no matter how good an engine or fuel system or anything else you have. So what I really want to talk about here is that the Stanley burner is of the Bunsen type. It doesn't need any electricity to fire. It's all done by first manually lighting it basically with a torch or a match, and it uses air and vapor of the fuel once the fuel is vaporized to fire. And the earliest cars, the ones that Stanley made before they were finally bought out by the group of men in 1899 or so, Tom, produced the locomobile. The burners in those cars were very unusual. There's a picture in the back page, the next to last page here, of what the burner looked like and the boiler. And although they were a single burner type system, the burner itself did not have a cast iron grate as the later cars had. It was shaped very similarly to the boiler. It was very short, but it had tubes in it, vertical tubes that were copper tubes. And I haven't quite figured out whether they were swaged or welded or what, but the picture on the right shows the top of the boiler, and there's a cutout there that shows the top of the burner. And the tubes are the bigger circles, and then there are these little dots around the circles. And they were drilled through the top plate of the burner, and that's where the vaporized fuel came up through. And you lit it basically with a match, or a taper as they called it. There was a little trap door in the side of the burner, and there was this gadget on the right where it says figure 343 was like a stove that you took out and heated up, and it doesn't say how you heated it. You were supposed to heat it up red hot, and then you placed that back in the burner where the square is now, the other picture on the left. And the fuel went through there, and it heated up and vaporized, and then you lit it with a match. And once it was lit, it would continue to burn because the fuel was being sent in there under pressure, just like the rest of the Stanleys. And the only difference basically was that since it was a single tube burner, or a single nozzle burner, it did not have a pilot. The fuel was regulated by a steam automatic, very similar to the later cars, but the steam automatic didn't shut off completely. The fuel was cut down to a very small jet or drizzle or whatever that continued to go into the burner, and it reduced the flame just about down to nothing as the steam wasn't needed anymore. So the whole burner basically stayed lit, but it wasn't enough to produce any steam. And then when it needed more steam, the automatic gave it more fuel, and we got more power. And then by 1903, they changed that design to the more modern style, quote, the cast iron burner grate, which we have one here. is this guy here. Hey, it's Joe Van Skyver. Here, Joe.
Good to see you. Sorry to be so late.
Pass that back to the latest visitor. This is basically the design of the 1903 burner grate, cast iron with these inverted ridges. It would have been like so in the burner. And what they did was they put this on a milling machine with a saw blade and they cut slots across these ridges. I guess about a quarter of an inch apart or so. And the fuel came through the nozzles and through mixing tubes that went in here. We got mixing tubes. These are bigger. They came up through here. And the fuel came through there, mixing with air as it came through. And it came out the end, and if these baffles weren't there, the fuel would go right up on this one part of the plate here. So they put these baffles there, and that made the fuel swirl around. And it kind of spread out in there, and then it went up all over the burner plate. So that's why the baffle. And they used a pilot. It was a separate pilot from the earlier cars that didn't have a pilot. And this is the vaporizer that they used. The fuel. Turn this over. Vaporizer would have come across like so. We got a there was a pilot and a vaporizer, and inside the vaporizer, this is an early vaporizer, there were cables, and the cables were put in there to force the fuel to the outside of the tube, and the outside of the tube is the hottest part of the tube, so the fuel vaporized faster being forced to the outside of the tube. In the earliest cars with the cast iron grate had what they call a single burner. This is a double burner grate. It has the two large holes in the front here. The earliest cars only had one. And this is, I guess this is the single tube vaporizer. And they were on the smaller burners and the smaller boilers, usually on the tiller steer cars, I think up to about 1905. And then when they came out with a 10 horsepower, they changed it to 10 or, yeah, I guess 10 horsepower. The first coffin those cars were 10 horsepower, isn't that so? They changed to a double burner that used two nozzles like this here. And this, the center one here, is the pilot. And they found out over the years that, and they were only this long, they only went across, like so, across the burner grate. And that was enough area to heat the gasoline, which is what they ran on, enough to vaporize it. In fact, the pilot got too hot. So they, somewhere along the line, you can see the center tube comes up and goes over top of the two bottom tubes, which are the vaporizers. And since the pilot casting lived here underneath it, like this, and it was lit all the time, that sort of cooled the vaporizer tube that the pilot fuel went through and made it vaporize okay. So, getting back to my story here. The earliest cars had the single burner, and then about the time the coffin those cars came up, which was 1905 or so, they went to a double burner, and that had two nozzles. This is the single nozzle type, and this is the double nozzle type. And then when the 30 horsepower cars came out, about 1908, they decided they needed another nozzle, so they put a triple nozzle. And the triple nozzle only lasted about 2 years, I think. They figured out it was so hard to control because instead of having just one valve to control it, they had 2 valves on the dash. And I guess you could run the vaporizer with 2 nozzles if you wanted to and not burn the third one, but it was built with the 3, so you burnt the 3, and then you had to control 2 valves on the dash. So I don't know, I've never driven one with 3 valves or 2 valves, so I don't know, but it looks complicated. There's a picture up there on the wall of the Model K that Tom's dad had in front of the house, and if you look real close on the front of the burner, you can see the 3 nozzles for the triple burner. So about 1910 they stopped making them. And I don't know if I said it, but all of these early cars burnt gasoline in their fuel system, both pilot and main burner. There was an inside burner pan that was crimped to this burner plate. And we have one here for a different burner. But this pan, this is for a bigger burner, there's another one on the floor there, was crimped over this edge here on the burner. And what that did, that kept all the fuel that went in here just in here. None of it could leak out and get exposed to other air, outside air. And it was crimped on there and was also cemented on there to really make it airtight. And the idea was to keep it airtight, so that fuel didn't get mixed with anything else. If it leaked out, it would tend to backfire and do all sorts of weird things that you didn't want it to do. So that's one of the things that was very important. Burners came in all different sizes. They started out at 14 and 16 inch. Then 10 horsepower cars, they made an 18 inch. And in 1914 they decided that 18 inch wasn't big enough, so they went to a 20 inch for the 10 horsepower cars. And since that was the last year for 10 horsepower cars, that's a pretty tough burner plate to find anymore. And the 20 horsepower cars were 23 inch burner, and the 30 horsepower cars were 26 inch burner. So all different sizes that they made over the years, all cast iron. And all of this style until the kerosene burners came out. Now for the fuel system, the main fuel tank didn't have any pressure on it, but they had what they called a twin fuel pressure tank system. And this was a patented thing that the Stanleys had introduced. Most of the other steam car companies had to put pressure on their main fuel tank, which with a gasoline tank was a pretty dangerous thing. But the Stanleys invented this twin fuel pressure system and patented it. And Tom doesn't have any here, but there's 2 little tanks, and they were mounted either on the dash of the car or underneath the car somewhere. And what you did was you filled the one tank with fuel with a hand pump, and then you got a hand air pump, and you put pressure, you pumped up the other one, you opened this little valve on the dash or under the car somewhere, and you connected the air pump to this, and you opened this up and you pumped air, and it went into the other tank, the pressure tank. And you put about 50 strokes of air in it, and then you closed this. And what that did, that would make a cushion of air in there against the fuel. And the fuel could be pushed by the pumps with that cushion of air in there, and then you didn't get that pumping thud, thud, thud every time the pump made a stroke. It was a cushion, so to speak. And that system worked very well. You put anywhere from 80 to 140 pounds of pressure that way, which was enough to push the fuel through everything to get to the burner. And you had a hand pump, and you also had a power pump. And the power pump worked fine when the car was moving somewhere because it moved off the engine. But as soon as the engine stopped going, like going slow up a hill or today in a parade or even firing up, the only way to get pressure into the system was with a hand pump. So that's why you see, you go to a antique car show and you see these guys firing their car up, they're just sitting there all day. You see them there pumping away, and that's what they're doing. They're pumping up that fuel pressure, because as soon as they start using that fuel, the gauge on the dash just goes down. You gotta pump it back up so you get right back in there and pump it up. And of course there were check valves throughout the system that kept the fuel running in the direction you wanted it to run. We didn't want it going the wrong. And there was at least one fuel filter or strainer in the system. Some systems had two. If you look at the diagram on the back page, and you really get your magnifying glass out, you can see there was two or three of them by the time the 740 was made, which is what this diagram is on. And the air recharge valve I spoke about for putting air pressure in the twin pilot tank was on the dash usually. And they had a little gadget called a steam automatic. And the steam automatic was for the fuel. I said fuel automatic. I don't know if I said fuel automatic. It was for if the fuel pressure got real high, as if the steam automatic turned the fuel off into the main burner, and you're driving along and that pump's pumping away for the fuel pressure, and that pressure gets up to 140 pounds, and hey, there's no place for it to go. The the fuel automatic opens up and bypasses it back to the main fuel tank, so that fuel has a place to go. And then when the steam automatic lets the fuel pass, then this closes off and the fuel goes back to where it's supposed to go. So that was a handy thing too, and that's something they invented too when the first Stanleys were made in the 1800s. And in the early days, when the gasoline systems were the only systems, the pilot burnt the same fuel that the main burner burnt, and it burned at the same pressure that the main burner burned. So you only had one pressure gauge, because you had one system of fuel, and although they didn't realize it at the time, they didn't realize it until the kerosene systems came out, that the pilot tended to carbon up faster with a higher pressure. But they didn't learn that until the kerosene systems came out. And I wrote down here the burner nozzle sizes when the Stanleys came out. If that means anything to you, get excited about that. And of course the burners on top of the boiler all had a hood, so to speak, and a stack for the gases to be carried off underneath the car in a way. Now the later models that used kerosene burners had a double system, a two-system fuel system. The main fuel system was now kerosene, and the pilot system still burnt gasoline. And this happened, according to Tom Marshall, about 1913, the late 1913 models. They started putting the kerosene burner on as the main burner fuel. And when they did that, they had to change the burner grate, because they found that the slots weren't good anymore for burning the fuel. So they went to something similar to it. And this is one we just took out of a car last week, and it had a problem we didn't know about. I don't know if you can see the crack in it. All this car used to do was backfire. Well, here's the reason, because this burner plate, the inside burner plate which was on here and crimped over, it had a leak. It was leaking out through there. So that constant pressure wasn't in there anymore. And although this was filled up with insulating material, what they call today the bad stuff, asbestos, you couldn't tell it was doing that. Even, if you looked in there through the pilot peephole, there was no way of telling, but we're learning that there was a problem in there. I mean, we put up with it, and finally we got the time and took it apart. But it's quite a, look at this, you can see it from the back, see how big that crack is? From here to here.
I trust you can still find those things.
Well, see, this is an unusual thing. That's a 1914 10 horsepower car, which has a 20-inch boiler in it. And they only made 20-inch boilers for 1914 cars. They were trying to find a 20-inch burner. This is a 23-inch burner that was put in there because they couldn't find the 20-inch burner in 1946 or something when they bought it. So this has been in there for 50 years and worked pretty good for 50 years. Yes, Jim?
Could that be welded?
Yeah, it could be brazed, I think, or I guess welded, but that's quite a wide crack. I don't know if that's made the thing.
It's okay. So
No.
Could you make the burner grate out of like sheet metal? Rather than cast iron?
I doubt if it would work right. They made them out of cast iron for some reason. The early ones were steel, I think, and they had all those tubes in them that were either swaged or welded, and evidently that didn't work very well, so they changed it. Yes, John?
If anybody's curious, I'm in the middle of a 1903, and I have the tube burner. I stuck it in the car. So
Do
if
you
wanna
really?
see
The
it-
one I was talking, the one in the picture there?
Yeah, I haven't looked. I got in late, but it does have the original. It's the correct burner
Oh,
for
really?
the car,
Yeah.
but it goes in a tube, and then it's like a T, and then it goes out, and then there's all these cross tubes and little holes in.
Well, that's different than this too. So they changed it. They probably changed it every 6 months. Or
Well, I think this was the intermediate between the locomobile burner and the cast iron with the slots.
Because I know Tom said the 1902 in here did not have the cast iron burner.
Yeah.
It's supposed to have the steel one. So, but it works much better with the cast iron, evidently, so that's why they went to this. But you'll see those inverted ridges that were on the other one aren't on this. The ridges are now flat. And then they drilled all these nice big holes in there. Size 54 drill size. And as you can see, that was a fun job. There's so many of them. This one probably has 5,000 of them or something. But that worked better with the kerosene. Evidently, the kerosene needed the smaller hole for the burn properly, so that's how they changed it. And they probably went through a lot of guys at the Stanley factory drilling holes. Did a terrible job. The vaporizer had to be longer. Since kerosene's a heavier fuel, the vaporizer had to be like this instead of this. This only this much of it was inside the burner. This from here, all of that was inside the burner. So, and I think Tom said it needed to be about 7 feet long. And then there was a cable inside of it that was put in from the rear end, and the cable went about 2/3 of the way around. And one of the reasons it only went that far is if it ever got choked up, they would never have gotten it out, because it would have choked the whole length of it. So they only put it 2/3 of the way, and also by the time the fuel got that far, it was pretty hot and just about vaporized, and the rest of the way it seemed to work all right. So that's all they did it. Later condensing cars had an even longer vaporizer, and some of the vaporizers, if you look at the picture here, go back to the one that looks like this. If you look at the burner, well, if you look at the steam automatics, this little circle here, there are 2 pipes coming out of the bottom of it, and each one goes to one vaporizer. So there were 2 separate vaporizers whenever this was made, maybe in the late teens or early 20s. And I don't know if that really worked out that well, but they did make them that way. Cable, it had, kerosene ones had separate forks in the front now. The early ones were made out of the same tubing that the vaporizer was made out of, but the kerosene ones had a removable set of forks. And this one welded on, but here's one here. The forks were held on by a large cap screw on the end, and that meant you could take the cap screw off and take them off and clean them, which was great. And they also had all these little screws that came out, clean out screws, so you could stick a wire or a drill in there and clean all the carbon out. You You guys might not think that that's such a great idea, but I've had them choke up, so that's a great idea. And they also had this piece of cast iron that was put on top of the vaporizer itself, and the pilot lived right here all the time. So the pilot burnt all the time, and that piece of cast iron, which should be really longer, but for some reason it isn't, spread the heat out on that little piece of pipe, and also sort of protected that little piece of pipe. So if it was going to crack, it would probably crack there from the constant heat on it all the time. So that's another improvement they made. And the nozzle sizes they changed again, and if you compare them to the other sizes, they're about 2 sizes bigger. And then they had to put a firing up valve on because they had a separate system for the main burner fuel, and the main burner needed to be heated up pretty good before it would burn kerosene. So they put a firing up valve on it, which put pilot fuel, which was gasoline at the time, into the main burner. And since that vaporized faster, that would tend to get the burner going, heat up the burner, and once that heated the burner up, then you could start putting kerosene in there, which by that time was warm enough after going through this long vaporizer to burn. And if we have enough time and get into the firing up process, we'll learn all about that. So the pilot design was changed, and for the pilot design, they had to add a few extras to the system. They had to put a separate tank in there for the pilot fuel, and they had to have a separate gauge for the pilot fuel, and they had to have one of these adding air pressure valves on the dash for the pilot fuel, and they had to have a lot of extra tubing and fittings for that tank. And this worked out so well the first year they did it in 1914 that people with earlier cars complained so much that they sold a kit to convert their cars to this system. So a lot of the cars that got restored in the 40s and 50s, you know, the real popular cars, had kerosene burners on them. And today, a lot of the cars you see anyway have kerosene burners. And the ones we've driven down here are mostly at kerosene burners. And although they do take longer to fire up, they are safer because of the fuel, and they seem to be more thrifty because of the fuel. All right, we're up to the pilot now. It's a small burner that works together with the main burner. Pilot. It consists of a small slotted casting placed near the front edge of the main burner. It would live right in here. And as you can see, there's no holes in the burner grate underneath it, so it would sort of stay cool there. And it now has a very short vaporizer. This little tube here is the vaporizer for the fuel. In the early days, they had that much from here to here area for the fuel to vaporize. Well, it was too much, and I told you they raised the pipe on top of the other pipe, so they found out that one 4 inches long was big enough to heat the fuel, to vaporize it, because it was gasoline. And they worked fine. There were some that were shaped like this. This is an original. It's a V-shaped tube. And nobody seems to know what kind of metal that was because it's very long lasting. Of course, this one got a hole in it. They found out that if they just took a piece of tubing and bent it, it worked just as good. This one's a little longer than this. And the casting was slotted like the earlier kerosene burners, and this burnt kerosene, so that was all right. It had a mixing tube, which is, I'm going to put this down, it'll It had a mixing tube, which is part of the casting here, and had a downpipe in front of it, which is this pipe here. The fuel would come in here and go through the vaporizer, come down here, and then come out through this nozzle here. And this nozzle had this screw on it with a little pin in the end. You can see that. See the pin? And the pin got carbon. But the pin also, besides just about obstructing that hole in the nozzle, a file was put to it to file a flat place on it. And when that was put back in there, the flat place was the only place between the outside wall of the nozzle and the flat of the pin was the only place that fuel could pass through. And that was enough under this extremely high pressure of 80 pounds or so with the gasoline models, and up to 100, well, 80 pounds with the gasoline. With the kerosene, they were down to between 15 and 35 pounds. It was enough to keep the pilot burning. And sometimes, which was frequently, carbon would collect on that little pin. And before you fired up in the morning, you would pull that out and wipe that off between your fingers. Put it back. And when you fired it up, and the flame was either lifting off the pilot grate, or it was not a blue color, you would put a screwdriver on it and you would turn it back and forth a few times. And that movement was enough to clean it off. And then you look in the little peephole and bingo, the pilot would be fine. So that was one of the interesting ways. That was called tickling the pilot. Now, since the main burner doesn't burn all the time, there's a steam automatic in the fuel line that would turn when the steam pressure got high enough to the point where it was just about too high, the steam automatic would come on and turn the fuel off. Well, the fuel would go off, the burner would go out. And without a pilot in there, the next time it came on, it wouldn't go on. But the pilot was in there, the pilot was on its own system, so the pilot burned all the time. So when the fuel pressure came back on, the pilot would light the fuel, and bingo, you'd be on. The burn of the pilot itself in the early days was pretty well attached. This is an outside burner fan here. We didn't really talk about it. The outside burner pan had some insulation on the bottom of it, and then the inside burner pan that was attached to the grate was set down in there. And this guy would have been right in here, although this one got one we can take apart. Sit in there like that. Yeah, that's too long. This doesn't go with that. This would be in here. And then there was an inner liner that left a space around here, and if you go to the one picture, the second picture in all the pages here, you see a picture of it. This one. You can see that space around the edge, that was filled with asbestos, and that sort of insulated the firebox from the outside. So that was pretty important. And this thing just was held up by clamps to the bottom of the boiler. And these slots around the edge were for the various pipes going in and out of it. And once it was held up there, and you got all the pipes on, the superheater and the vaporizer and whatever else, then you had to mix up some insulating material. It was like putty, so to speak, and form it around those openings, because if you didn't close those openings up, you'd have the fire coming out the sides of the burner plate, which you didn't want with a car that had fuel and fumes and a wooden frame and things like that that would be very injurious to it. So that was another few things to think about. And the main fuel tank, since it didn't have any pressure in it, and it was a kerosene-fired car, you could basically put fuel in it anytime you wanted to, even with a fire on. But if it had gasoline in it, you better not put anything in it, better not open it while you have fire on, because of the fumes, explosions, and things like that. The cushion of air has to be pumped in the pressure tanks every other day, because some of it dissolves in the fuel, and that's so true. And a good way to tell while you're driving along is to look at the fuel pressure gauge. And if the fuel pressure gauge is nice and steady, then it's fine. But if the fuel pressure gauge has a little movement in it while you're driving along, that's the pump coming through with no cushion of air. And you can almost count every stroke of the pump if you see that happening. Sometimes it'll be a vibration. The worse it gets, the more it'll do this. When we were in Canada 2 years, we couldn't understand what it was. It was going like this. We asked the right guy and found out we needed an air cushion in the pressure tank. So we got a bicycle pump and we put it up to this valve and we opened it and we pumped about 30 times. Put that cushion right back in there and it ran fine after that. But evidently, a lot of these cars get driven without enough air in there, so you might, as I said, you might have to let the pressure drop to 80 pounds and put about 40 pounds of air in, and that might not be enough. You're going to have to do it again to get enough of a cushion of air in there to make it run all right. And as I said, it runs with about between 80 and 140 pounds of pressure, depending upon the year of the Stanley you're driving. If there's nothing shut off between the pressure tanks and the burner, the fuel will go directly through. But there are things between the pumps, the pressure tanks, and the burner that can stop the fuel. There's always a hand shut-off valve on the dash. Now that'll have to be shut by hand. And a lot of times, a lot of these cars have a shut-off valve at the fuel tank too, in case there's a problem between the one on the dash and the pumps and the fuel tank. It's nicer to have a way to shut it off than have to drain everything out of it. There's what they call a pressure retaining valve. Pressure retaining valve was on the early cars up till about 1917 or 18, I believe. And it was put on there so that if you stopped and had to leave the car for an hour or two, you could shut it off and it would hold the pressure in the pressure tanks and relieve it from the pumps. There was a good chance it could leak out of the pumps because of packing. So they thought that was a good idea, and when the condensing cars came out, they decided they didn't need it, so they didn't put them on. There was a low water automatic, which I'll explain later on, and a steam automatic, which I've talked about, and of course check valves along the line. As I said, the hand shut-off valve was on the dash, usually on one side or the other from the steering column, and it was a very short stem valve, and that has a lot to do with how they tell the valves from each other, the length of the stems. If you've ever looked at a Stanley dash, you wonder how anybody could figure out what all the valves are. And that's one way for the operator to tell not only location, but the length of the valve stems. And I told told you, the pressure retaining valve, its location is on the floor to the right under the driver's feet. If you've ever looked at a Stanley, there's at least two valves there, and the one on the right is a pressure retaining valve. The low water automatic, which one here, George? Low water automatic was put on the car to stop the boiler from being ruined by the water level going down too far. It would actually cut the fuel supply off to the burner if the water got low enough. And it was usually put on the boiler about 4 inches from the bottom, and water would fill it. This is a hollow tube, and this went into the burner, or into the boiler. And on the other side of this was what they called a tricock valve. And when you fired up in the morning, you always opened that valve to see if there was enough water in the boiler, because you knew that was 4 inches from the bottom of the boiler. So you would open that, and if water ran out of there at a pretty good clip, then you knew you had enough water to fire up. But if the water level in the boiler got below this tube that had water in it would drain out, and the steam would get in there. And when steam got in there, it would expand this tube and make the valve up on the top close. And the fuel went through there all the time. And when that closed, it stopped the flow of fuel, so the burner stopped working. And if this happened to you, and you had no idea what was going on, all you really had to do was come out and touch this thing, because normally this was pretty cool. The top of it was closed to the water when it was full of water. And it didn't have water circulating through it, so it was pretty cool. And as soon as it filled with steam, it got just the opposite, pretty hot. And if you touched it or spritzed some water on it, and it would, you know, pretty well it had closed. A lot of people don't know whether they work in their cars because they don't want their water pressure to get down to 4 inches from the bottom of the seat. So, and I guess Tom doesn't know if any of his even work, but really about the only way, I guess, to find out is to let that happen.
Well, you're really supposed to be able to test them by blowing your water column there at the tricock or at the blow-down valve on that side with the fire on, and supposedly the water column will heat up even though your level in the boiler is still higher, and we'll shut this thing off. But I don't like to test them.
Not a good idea.
But it's a great idea. And the earlier cars had a fusible plug in basically the same place. It was a piece of lead, a round piece of lead that was driven into the boiler itself. And if the water level got down, as long as water was over it, it was fine. But as soon as the water level dropped down to it or below it, the steam would hit it, and the steam would melt the lead and knock it out. And the only bad part about that was, if you were out in the middle of nowhere, and it happened, you'd lose all the steam pressure and all the water, and you'd just die wherever it was. And you'd have to wait for everything to cool down, and then you'd have to find another lead that you're supposed to have carried with you and drive it in there. And then you had to get the water back in there up to that point before you could fire up. And if you had enough water in the tank, that was fine, but the only way to do it was to pump it by hand. And Tom says that's about 2 hours of pumping by hand. And you got to go through a lot of arms and a lot of friends and whatever else to do it that way. So this is a much better arrangement. Fuel automatic we talked a little about. Looks like the steam automatic, and I don't see a steam automatic. There's a steam automatic. Just a shorter version of the steam automatic. Fuel passed through here on the way to the burner all the time, but when the steam automatic stopped the fuel from flowing and the fuel pressure built up, this would divert it back to the main tank. So this was a safety feature so that the steam pressure or the fuel pressure didn't get too high when it got to the high setting, which was between 80 and 140 pounds depending upon what year. divert it back to the main fuel tank, which was not under pressure. And that was a good idea. I'm going to read what the steam automatic does, because I think it gets explained better in here, and I'll talk a little about it. The steam automatic, its function is to regulate the amount of fuel going to the burner so as to maintain a constant steam pressure. The rate at which steam is used from the boiler varies considerably with the speed of the car and the conditions of the road. The steam automatic provides a proportional amount of fuel to the burner. The steam automatic consists of a flexible metal diaphragm, which is up here between the screws, between the upper and lower sections of the hollow casting. Steam pressure from the boiler enters the top, and a coil spring, which is inside the part where my hand is adjusted against the lower side of the diaphragm. The spring is set to balance the steam pressure, so at the normal boiler pressure the diaphragm takes a neutral position. The diaphragm therefore moves with every variation in steam pressure in the boiler, and a very simple arrangement of a stem from the diaphragm to a valve in the fuel line gives a simple and dependable automatic control of the fuel line. When the steam pressure in the boiler falls below the predetermined amount, usually about 400 pounds, the pressure on the other side of the diaphragm is reduced and the spring lifts the diaphragm, which with the stem attached to it opens the valve in the fuel line and lets the fuel flow to the burner. More fuel means faster steam generation in the boiler and the pressure goes up. This pressure, of course, affects the diaphragm, forcing it down against the spring and moving the valve stem so the fuel shut off again. This automatic device relieves the driver from any attention paid to the burner in steam generation. And the automatic's usually set to turn the fuel off at 500 to 550 pounds. So not only does it turn it on and off, but it slows down the rate that the fuel can pass through to the burner. So if the car runs graded with 450 pounds of pressure in the burner, in the boiler, this is set. This will just let enough fuel through there to keep it running at that speed, or that pressure. But if it drops down to 350 pounds, this will open wide and let all that fuel go into the burner. And that'll produce a lot of steam, and then it'll shut down again. It's a continuous thing, and when it's working, which it usually does, it usually works fine all the time. The car we drove on the last tour, before the last tour, we were having trouble with, there's a blow-off valve. When the steam pressure gets above what it's set for, there's a blow-off valve on the boiler that actually lets the pressure go on.
Is that adjustable as far as set?
This is adjustable with this set screw here.
Yeah.
And I think 1/8 of a turn is 25 pounds, if I'm not mistaken. And the boiler was going up to about 600 pounds, which is more than this is set at. And the blow-off valve would let go. So we figured it was in the steam automatic. We took the steam automatic off, took it apart, and this spring in here is a hell of a spring, if you don't mind the French. We pulled that spring out, and when you held it up to the light, you couldn't see any airspace through it. It was rusted so bad that it just wasn't compressing anymore, so it wasn't shutting the steam off until it really got a heck of a load on this end, and then it finally would shut it off. Tom looked around, and lo and behold, it came up with another spring. So we put another new spring on it. It's been fine ever since. So that's the only time I've ever seen one give trouble. And of course, you can set it anywhere you want, but you have to remember if there's a blow-off valve, that's going to go off if you set this too high.
Sounds like there's a dwindling supply of parts.
Here's one of the diaphragms, which really is a piece of brass. This is probably a bad one. Get cracked, but that's really what does the work inside there. And although it seems easy to move with no bolts around it, you get that all bolted in there, and then that's a pretty tough thing to do. But that's what the steam does, is move that enough to shut the valve at the other end. Burner forks came out. These are the burner forks. Came out with the kerosene cars, and they were removable, and made it easier to clean them when they got dirty, and they do get dirty. I don't think they do, but they get dirty. The nozzles had to be cleaned. You should really clean them every morning before you take the car out on the road. Or you should take them out and take a wire